Let me check homework a little bit later into class. If you can turn to page 5, I'd like for us to continue practicing with preparing for your test on Thursday. Now, in your packets, if you can identify these problems, we're going to omit these following. These we're not going to worry about preparing for on the test. So on page 2, you can cross off 3B and 3C. Page 5, you can cross off 1B and 2B, like what we see here. So I'm not going to ask any questions about domain on the test. For page 6, you can cross off 3C, 3D, and 3E. And then page 10, I won't give you an arbitrary one where the negatives are difficult to manage. So we'll create a different version of number 6 on page 10. So you can cross that off as well. So page 5, let's go ahead and work on a differential equation. So it says find the particular solution. Let's go through our steps. Let's see how we do. Okay, so part A, find the particular solution. So we're going to go through all our process here. Start off cross multiplying. You can solve for C at this point, or you can wait. I would prefer to wait a little bit longer here to kind of get that, wait until that 2 goes away. So I find that this is an easier spot for me to solve for C, but again, you can solve for C at any moment in time. I just find it a little bit cleaner when the 2 has been distributed and I can get that denominators out of the way. So at this point, think it's easier to plug in and solve for C. Okay, so our goal here, we can solve for C, and then we can work on solving for Y. So -2 in for Y, -3 in for X. Update our equation, y squared is equal to x squared minus 5. Fine. Once you have y squared by itself, once we have c figured out, I can solve for y, take the square root. But when you take the square root, there's going to be plus or minus that shows up. How do we choose between these plus or minus square roots? Because these are two different functions. Which one would we choose, the positive or the negative square root? Negative, because why? The y value is negative. Yeah, so the sign will always match whatever your y value is. Again, the goal is if I plug -3 in, the only way I can get a -2 is if there's already a negative outside my square root. So my y is going to be a negative square root x squared minus 5. Again, if you guys came in late, on the board there, I have omit the following at the top of the board there. So you're going to omit page 2, number 3B, 3C, page 5, 1B, and 2B. So that's what this page is anything but domain we can remove. And then page 6, 3C, 3D, and 3E. And then page 10, number 6. So you can cross those problems out and don't have to worry about working those in preparation for the test. So part C, it says find the equation of the tangent line x equals -6. So part C, find tangent line equation. So whenever you see find a tangent line equation, this should feel like an easier process than solving an equation. So I want to make sure that we don't get these two processes mixed up. This is a first semester topic. Solving a differential equation is a second semester topic. So all we need for tangent line equation is we need to find order pair and slope. Right? Now we have an equation for us, so we can use this to find our order pair, and then we can use this to find our slope, and then we can do point slope form. Right? This is the equation. This is the derivative. All right, so we need to find point. We know what our x value is, right? Our x value is -√6. And we need to find the slope. So to find the point, plug -√6 in for the x, get our y. So -√6 in for x, I get -√6 squared, which is 6. 6 minus 5 is 1. Square root of 1 is 1, and then we have -1. So my y value is -1. We're just using the equation to get our order pair. Next up, to find our slope. Our slope comes from our derivative. So x over y. So my x is -√6, my y is -1. So my slope is just +√6.
All right, let's build our tangent line equation. Y minus y sub 1 is equal to m times x minus x sub 1. Box this off. That's part C. And part D says use this to approximate y of negative 2.5. So all we do is insert this negative 2.5 into the what? What do we plug this into? How do we do linear approximation? What does this replace? Dx. Yeah. So linear approximation, you're just dumping that decimal into the x and then getting your decimal value. So let me write y first. Let me just move that 1 over to the right side, and that way it'll just feel a little bit cleaner. So now y of negative 2.5, it's just whatever this decimal is. And this is just a calculator entry. Okay, so you'll see a problem like this on the test where you're solving a differential equation, and then you may be asked to find the tangent line equation, but tangent line equation, you're either given the order pair or you're given a part of the order pair, and you got to plug it into an equation that's either given to you or one that you build. And then your slope is found by plugging into your differential equation. That's just a fancy word for derivative function. And then point slope form, and then decimal into the point slope form for your linear approximation. So that covers topics 1, 2, and 3 on the board there. Yeah, question. I'm sorry. Yes, yeah, you get to use calculators on the test. So let's practice this. Thanks. Let's practice this procedure. For number 2. So page 5, sorry, page 5, number 2. Let's do 2A, 2C, and 2D. So part A says find a particular solution. So we're going to go through all of our process, separating our variables, taking the antiderivative. Let's try that. Cross multiply. X dy equals dx. Our dy and dx's are in the right places, but do we have full separation of variables yet? Not yet, right? We have the x that's out of place. So we want to move that x over to the right side on the same side as the dx. Right, now everything is nicely separated. Maybe I can rewrite this in a form that feels easier to recognize. All right, what number is hidden right here? It's a 1, right? So hopefully that makes it easier to see what the integral is. What's the integral of 1 dy? Just what? Just y, yep. So y is equal to, this is just natural log absolute value of x. No need for u substitution. Plus c. This one is a little bit easier. Okay, let's find, I mean, it's nice that we already have y by itself, just the only thing left is to solve for c. So plug 1 in. One in for x, one in for y. Okay, so now we can create our particular solution. So there's part A. All right, I want you to see if you can try part C. All you're doing is finding the equation of tangent line. At x equals e, so you know your x value, you need to find your y value. After you find your order pair, use this to find your slope, and then point slope form, tangent line equation, and then the last part D, dump that decimal in. So try those steps, want to see if we can get through part C and D on our own. So I can plug e in for x to get the y value. So natural log of e is 1, 1 plus 1 is 2. So my order pair is e comma 2. My slope is coming from my derivative equation. So dy dx is 1 over x. So 1 over e is my slope. Once I have my order pair and my slope, point slope form, there's my tangent line equation. Linear approximation, y of 2.8. So all that's doing is just plug that 2.8 in for x and then use your calculator to do the rest. Let me solve for y first, though, just to get that 2 over to the right side. In your calculator, if you want to plug E into the calculator, you could do E to the first power, which is natural log, but there's also an E button right next to that, right on that division sign there. So if we do second division sign, it'll just pull up that E. So just showing you, there's two places that you can pull the E. You can do E to the first power, or just do the division sign and just do one, and just do E for that. All right, any questions? Okay, let's do a word problem involving y equals c e to the kt. Let's do it. Go to page 6. So anytime we see this y prime equals ky or p prime equals kp, you know you're going to end up with y equals ce to the kt. You know that's going to be your general equation. So that's our starting point. And we're skipping all the differential equation process because we know that's, if we separate the variables, take the antiderivative, it's always going to lead us to this. Okay, so we know that with these problems, we're just creating a bunch of order pairs and then plugging in one at a time. So in this case, time and temperature is represented with T and Y. We always want to involve T equals 0 to help us with our equation. So it says the initial temperature is 190 and temperature decreases to 76 degrees after 5 minutes. So anytime we see the word initial, that's the indication that you want to use 0. So at time 0, the temperature is 109 degrees. And then after 5 minutes, 76 degrees. Okay, so we'll plug in one at a time. We'd like to involve the 0 order pair first because 0 will wipe some things out. Or if you just understand what's going to happen here, this is basically your C value. If I plug 0 in for T, all this will go away. I'm just going to be left with C equals 190. So you can jump into that conclusion or you can go through your steps to convince yourself. K times 0 is 0. E to the 0, anything raised to the 0 power is 1. So this just goes away. So C equals 190. Update your equation. And now you can move on to your second order pair. This will help you solve for K. So 5 in for T and 76 in for Y. And then we're just algebraically trying to solve for K. K is stuck in the exponent. Eventually, we do want to involve natural log, but first, let's get that right side cleaned up. We can move that 190 over to the left first. $76 over 190. I think that comes out to be a nice number, hopefully. 0.4. All right, take the natural log of both sides. The reason why we want to take natural log of both sides is we want that exponent to come down in front. We want to use that log property available. We know natural log of e is just equal to 1, so it's going to go away. We can just solve for k. Divide both sides by 5. Now we can update our equation. We have c figured out. Now we have k figured out. We can rewrite our equation with the c and k filled in with numeric values. So y is equal to 190 e to the natural log of 0.5, or sorry, natural log of 0.4 over 5. All right, any questions here? So basically, these problems, this type of problem has no calculus in it. I mean, the only calculus is getting from the differential equation to this equation. But once you're here, you're just plugging in, solving for a variable, updating the equation, using some log properties here and there, but there's no calculus except to get to this equation here. All right, part B, for find how long it takes for the temperature to decrease to 50 degrees. So this is our third order pair with a missing piece. We know that we're looking for some time when the temperature drops down to 50. So plug 50 in for y, and then we can focus on trying to solve for t. So divide by 190, take the natural log of both sides, bring the exponent down. Sorry, divide by 190, sorry. Oh, and then I do want you to hold on to your exact K value. Don't do a decimal version of that. I want to hold on. I want you to you show me your exact K value. No decimals until the very end of the problem. Take the natural log of both sides. Now that we're inside a natural log expression, our exponent can be free to come down. We know natural log of e will just go away. So the only thing left is just use your calculator to get the decimal version. So it's the natural log of 5/19 divided by 1/5 natural log of 0.4. Page 10. Let's do a matching problem. So the things that we like to look for is where do you see positive slopes? Where do you see negative slopes? Where do you see slope zeros? And then where do you see slope undefined? Okay, take a look at that. See if you can. One thing I noticed is that my first quadrant and third quadrant are positives. Second and fourth are negative. So a lot of, just with first quadrant being positive, I should be able to take out a bunch of these, right? Because A and C doesn't, sorry, A and B don't quite fit that category, right? Any order pair that I plug in, I'm getting a negative in return in the first quadrant. We know that can't be true. So we're down to C and D. And then even D, I can imagine some order pairs that can produce a negative in the first quadrant, right? If I plug in order pair 2, 1, this is giving me a negative. I don't see any negatives here. So looks like it's easy to see that x over y. Another thing that is nice about x over y is that anytime your x and y's are the same, like 3 over 3 or 2 over 2 or 1 over 1, you're going to get a bunch of one order, a slope of 1. So 2, 2, 3, 3, 4, 4. You see all that here as well. these are all showing up to be ones because the fact that if I'm dividing x and y that are the same, I'm getting the same slope. Likewise, if I had like -3, 3, if the signs are different, but the numbers are the same, I'm getting a -1 slope. We see all these -1 slopes here. Bottom of the page here, these are all use substitution problems. I just want to talk about the first step because everything else should feel easier to work through. If you look at number 4 here, what do you think your u value could be? Right? You see a set of parentheses? So that's usually a good place for us to look for our u value. Okay. Number 5, negative sine x, 3 to the cosine x. What could be our u value here? Or what rule could we try to move towards with this problem? This looks like a what rule? Yeah, the a to the u, right? So if I'm targeting a to the u, then I want my exponent to be my u value, if that's right. And if we can find the derivative of cosine, that should match up nicely with negative sine to cancel out. Right? So our u value is cosine of x. And then number 7, what's our u value there? Parentheses, right? Okay, we've pretty much covered everything up there on the board in terms of types of problems. So let's cross off number 6, and let me do one, see if you can recognize the process here. The integral from 2 to 3 of x cubed minus 2 over x plus 1 dx. All right, can you recognize this here? What process is this problem? All right, from your quiz, right? What is this? Synthetic division, right? So synthetic division has a certain look to it. You're always dividing by like x minus 2 or x plus 1 or x minus 5. And you're going to go through your process. Okay, so let's practice a problem like this. So first thing is make sure you always choose the negative or always set that equal to 0. And you're always going to end up with the opposite sign of the number that you see there. So we're going to choose -1. Half box. Now we have 1 for x cubed. What do we have to be aware of? Bunch of zeros, right? So 1 for x cubed, 0 for x squared, 0 for x, and the -2 is my constant. So I have 2 zeros that I need to account for. Right? We always drop the first number below the line. So this is a 3, you're going to bring down a 3. If this is a 4, you'll bring down the 4. In this case, it's a 1, so you're going to bring down the 1. Right? Multiply and add, multiply and add, multiply and add. Okay, we're still at the integral stage. In an integrand stage, we haven't found the antiderivative yet. What is our first term going to be? What power? X to the what? Second, yeah. So if I start with x cubed, in my problem, I'm dividing by x, so I'm going to be dropping down by 1 degree. So 1x squared plus, or sorry, minus x plus 1. And then the last is your remainder. And just know that all these are going to be separate problems. The first few will be just power rule, and the last one is a little bit of natural log. So x cubed over 3 minus x squared over 2 plus x minus 3 natural log of x plus 1. Normally we'll do a plus c, but why do we not do a plus c here? We have bounds. Okay, so then we plug in 2 and 3. And if you plug in your upper and lower bounds, you don't have to clean anything up. You can just leave all that mess there. So 27 over 3 minus 9 over 2 plus 3 minus 3 natural log of 4 minus big parentheses. And then repeat the same thing with the 2. 8/3 minus 4 over 2 plus 2 minus 3 natural log of 3. And I saw this on the quiz where some students, when you see bounds, some students still want to do a plus c. So we don't do plus c's anymore. If there are bounds, the c's will just go away. So this is also acceptable on the AP exam. You don't have to clean anything up unless there's trig. If there's trig, then you have to evaluate that trig down to a ratio. But you know, on the AP exam, this is acceptable. You don't have to clean anything up once you plug in your upper and lower bounds. Any questions? So I'm going to come around and check your homework in a second, but I think if you can turn to page 13 for a second. 13, page 13, 14, and 15. I think this is a great last review for you to do before your test on Thursday. So I will go through page 13, 14, and 15 for the morning review on Thursday. It's got everything in it, and I feel like if you can do page 13 to 15, you should feel really good about the test. And then also on page 21, sorry, page 19. Page 19, there's a blank practice sheet. I think it's good for you to practice those rules. Let me cross off the ones that you don't have to maybe worry about. So rule number 9 and 10, those aren't as important. So, and as far as arc trig derivatives, we don't have to worry about the arc trig derivatives either. Okay. So I want you to know your original derivative rules, your natural log, your e to the u derivatives, and then all your integral rules on the back. Okay, page 20. And then the key is attached on page 21 and 22. So it's good if you can practice through this and then check your rules. All right, let me check page 7.
Yeah.
We'll start our next unit tomorrow, but we can still spend some time reviewing, and your test is Thursday.